Hello everyone, my name is hw3 and I'm going to talk about the problem 1 of the homework 3. The problem 1 is that we have known the probability of x equals to k is b multiplied k multiplied p to the power of k minus 1. For k belongs to 1 to 3 to the infinity, and p is belongs to 0 to 1. Now we look at the first question. Question A is to find B so that the P represents the probability mass function. For that, P is the probability mass function. We have the information that if we sum up this, k is from 1 to the infinity, the value is 1, so that the P could represent the probability mass function. We could satisfy the condition. So that we just need to know this part, because this expression is equals to B multiply the sum. So we need to solve this part. This part is k is from 1, so first part is 1 multiply p to the power of 0 plus 2 multiply p to the power of 1 multiply plus 3 multiply the p to the power of 2. This is the first formula. And now we multiply p to the both sides at the same time. We could get the second formula is that multiply p is 1 multiply p to the power of 1 plus 2 multiply p to the power of 2. Now we could let the first formula minus the second formula. We could get that we could know this part is very easy to solve. Let this part divide by 1 minus p. We could get this part we need to solve. So the result is 1 minus p to the power of 2, so that b multiply the 1 divided by 1 minus p to the power of 2 is equals to 1, so that b equals to 1 minus p to the power of 2. That's the answer of the first question. Look at the second question. The question B is to find the expectation of x. Firstly, we need to write the expression of the expectation of x. Expectation of x should let k multiply every probability. Let every k multiply every probability. Then sum up that. Is the expression of the expectation of x, which equals to b multiply k to the power of 2 multiply p to the power of k minus 1. we could put the b to the outside. To solve this part, we have the information which we get in the question A is k multiply p to the power of k is p divided by 1 minus p to the power of 2, so that we could differentiating both sides with respect to p, we could get what we want is 1 plus p divided by 1 minus p to the power of 3, so that the expectation of x is equals to b multiply 1 plus p to divided by 1 minus p to the power of 3. We have known that the b equals to 1 minus p to the power of 2, so that the expectation of x is equals to 1 plus p divided by 1 minus p. Let's answer the second question. Look at third question. Sorry. The third question is to find the expectation of x squared. So the expression becomes b multiply the sum of k squared multiply k multiply p to the power of k minus 1 is equals to b multiply the sum of k to the power of 3 multiply p to the power of k minus 1. So we need to solve this part. This part we should use the information we get in the second question. We have known that the sum of k squared multiply p to the power of k is p multiply 1 minus p and then divide by 1 minus p to the power of 3, which is p plus p to the power of 2 divided by 1 minus p to the power of 3. So that use the same method, we need to differentiating both sides with respect to p. We could get the part we want is then let b multiply this result. We could get the expectation of x squared is p squared plus 4 multiply p plus 1 divided by 1 minus p to the square. The question D is to find expectation of x squared minus the expectation of x then to the power of 2. This part is resolved in the question C is this minus the expectation of x we solved in the problem B is 1 plus p divided by 1 minus p. and we could get is 2p divided by 1 minus p to the square. That's the result of question D. Lastly, we look at the question E. Question E is that p equals to 1 divided by 3. Find the conditional probability mass function that firstly we rewrite this expression, which equals to the probability that x equals to k and x belongs to 2 from 2 to the 5. Then divide by the probability that x belongs to 2 to the 5. This is very easy to solve, so we have the expression resolved in above questions. When this satisfies when k belongs to 2, 3, 4, 5. And if otherwise, if k doesn't belong to the 2, 3, 4, 5, the expression is 0. That's the answer of problem 1. Thank you.